This is my lab 4 bar magnets lab. So for introduction, as a purpose, we were to investigate how the magnetic field from a small bar magnet depends on the distance and compare those measurements with the on and off axis field that are predicted by the Biot-Savart law. So in terms of the analysis, we used the glow script to create a computational model to see our magnet's theoretical field, and then we compared and predicted that to the experimental values to see how the field magnitude changes with distance. So as a brief overview of our main results, the magnetic field weakens as the distance from the magnet increases. That's what we found to be true. And on the magnet's parallel axis, the field was roughly twice as strong as the perpendicular axis. And these were the derived parameters that we got with an n of negative 2.67. So the fundamental concept used in this lab is the modeling of the magnetic field versus the distance, in which we approximate the bar magnet's field as V of bar, which is equal to the K times R to the power of N, and we would take the log from both sides to get us our equation. We also use the Biot-Savart law in the vector form with B equal to mu naught over 4 pi r cubed times the vector. And on an on-axis field for dipole approximation for the large R, where R is much greater than the magnet size, the B, the dipole at the axis, was equal to mu over 4 pi r cubed. So the initial conditions for this lab can be seen in the picture above, where we marked the relevant component of Earth's magnetic field in the data table. And on the on-axis location on the phone using the tape, we collected our initial measurements. With that same setup, we also found the perpendicular distance for the magnet with the net field when it reaches a particular target value, and noted that distance once again. We did this 2 more times for repeated distances and got a net value average and distance. So for the system and surroundings of these experiments, the system was the phone and the magnetometer, and the surroundings were the bar magnet and everything else around it. And for the procedure, we ignored the x component because it barely changed, and found the spot where the b of the x is maximum and the by was minimum, and that is what gave us our sensor for our phone. So this is our data and calculations. We had a slope of negative 2.67 with the ideal aim of negative 3, and that was all the data we filled in. We noticed that the x component of the magnetic field grows larger as the magnetometer approaches the bar magnet, and at large distances that x component was essentially 0. So this was our glow script code, and this was the resulting program. The results were the observed off-axis field with a vector of 4.1 times 10 to the negative 5, negative 2.92 times 10 to the negative 5, and negative 2.45 times 10 to the negative 5, giving us a total magnitude of 5.6 times 10 to the negative 5. And for the computed off-axis field, the magnitude was 3.49 times 10 to the negative 5 with no z component. So in terms of that, the sources of error would be the measurement inconsistencies interfering with nearby electronics, and then having unwanted phone movement during data collection. So to answer any additional questions, if we had oriented our experiment to compensate for the magnetic north and then instead laid out with respect to Earth's magnetic field, it would be a less predictable way. It could be a larger or smaller fraction of Earth's field at each position depending on that relative angle, and this would lead to systematically shifted or inconsistent data, since the experiment assumes the idea that Earth's field contributes in a known direction and can be reliably subtracted out. For the second additional question, that if we were to stick two identical magnets together end to end and run the experiment again, how would it change? The combined magnet probably would have a larger dipole moment, and in simpler terms, it would behave like a stronger, longer magnet. The field distribution would also extend further along the new, longer magnet's axis, making the near field region larger and possibly altering the shape of the E field. So this was lab 4. Thank you.